Today we've got a great panel for you. We're going to be addressing opportunities and risks in open source hardware. And I'd like to invite the panelists to come on out now. So first we have Tim Whitfield. He is the VP of Embedded and Automotive Strategy at ARM. Joseph Jacks is the CEO and founder of OSS Capital. He's a veteran of the open source software industry. Mendy Furmanek is the president of OpenPOWER, and of course, Krste Asanovic, who is a professor at UC Berkeley, as well as the chief architect at SiFive. In the interest of time, I want to make sure that we leave enough space at the end of the session here for all of you to ask questions of the panelists. So I'm not going to dive really deep into their illustrious bios. You can find them on the RISC-V Summit website. So if you want to check that out, feel free to do that at your leisure. So there are obviously a lot of opportunities in open source hardware. That's the reason we're all here today. There are also significant risks. We're going to address 4 key areas this morning. The first is where we are with the state of open hardware today. The second will be how organizations are going to be able to manage the potential hidden costs of developing with open source hardware. The third is then navigating fragmentation and interoperability issues that may arise. And finally, we'll dive into some of the legalese around patents and IP, et cetera. So without further ado, as you already know, there are mic stands at the ends of those 2 aisles, so feel free to walk up when we're through those 4 topics and have your questions ready. But we'll just kick it off with Krste. So by your definition, when you started working on RISC-V, what is open source hardware and where are we with it today?
Yeah, I think one very important point that I'm going to keep emphasizing throughout the panel is the difference between an open standard, like RISC-V, and open source hardware, which is source code for some hardware blocks, some RTL. So when we started RISC-V, we saw a need for an open standard. And at Berkeley, we also developed open source implementations of the standard. But by far the most valuable thing is the open standard. Mm-hmm. And open standards, the thing is you cannot have open source hardware without an open standard. Mm-hmm. But it's also true in the industry, we have hundreds of open standards that many of them only have proprietary implementations, and that's fine. But the key thing is, I want to emphasize, open standard is where the big value is. Open source hardware is enabled by it, and it's a much earlier stage. Open standards are widely accepted, widely used throughout the industry. Open source hardware implementations of those standards, that's a relatively new thing. But the key thing about RISC-V is it is an open standard that's enabling a lot of things because you need a processor to run software on any kind of hardware platform. And so that's why you see this upsurge of interest in open source hardware, because the ISA open standard enables people to build open source hardware.
Very good. Moving over to you, Mendy. So what is it about open standards and then subsequently open source that attracted the OpenPOWER Foundation to move in that direction, and what are the opportunities you see moving forward?
Sure. OpenPOWER Foundation started in 2013, and our focus at the time was to really build out the power ecosystem starting at the system level. So it was opening reference designs for others to build power systems beyond the systems that IBM builds. And with that, we were focused on opening up the entire firmware stack as well as fully open system through the software stack. And so coming into 2019, we went to the next step and said, it's time to open the instruction set architecture so we have a fully open system stack. So we kind of came at it from a different direction of building out that software ecosystem, that system level architecture, and then going to the instruction set architecture. And I fully agree with Krste. There is a difference between the standard, the instruction set architecture, and then open source designs. So when I say, opening the instruction set, I'll never say open source instruction set.
Right.
Those don't go hand in hand. It's open designs and then an open instruction set, which is an open standard that you can build upon.
Very good. Moving on over to you, Tim. So there have been some changes lately at ARM with how you're handling the licensing and programs around your lower end cores, and then also custom instructions were recently released. What is that a result of some of the momentum that's being gained in open standards and open source? Coincidence?
I mean, if you look at ARM over 30 years of history, I mean, I think it's fair to say that we've constantly evolved our technology to meet the requirements of our partners and their customers, right? So there is undoubtedly another inflection point. I mean, we've seen it today and yesterday in all of the presentations as we move to a world of trillions of connected devices, a world that's really driven by data, enabled by 5G, ML, AI. So, there is an inflection point, and what worked for a world that was dominated by mobile clearly doesn't work for a world that's dominated by different design philosophies. So, yeah, ARM have continue to evolve, and they will continue to evolve. Is it a direct response of RISC-V? No. There's lots of movement in the industry, and we need to respond. Our customers are asking us to do things in certain ways. So, that's why we evolved our business model. It's why we will continue to do so and embrace a lot of what we've seen over the last 2 days. Right? We recognize the same trends that have been talked about here.
Very good, Joseph. Can you compare and contrast some of the opportunities that you see with open source hardware and these open standards that are driving that open source hardware, and what you've experienced over your long career in open source software?
That's an interesting question. I think there are some transferable comparisons that you could make from like the open source software ecosystem and this open source hardware ecosystem we're starting to see grow quite a bit. If I had to think about maybe the most sort of obvious similarities, it would be, Linux was very disruptive to Windows and proprietary operating systems before it, Unix obviously, and unlocked a huge amount of innovation and sort of value creation on the internet and in the growing developer community. I think RISC-V and the open standards dynamics that Krste and I think open standards are definitely independent of open source, but the similarities are pretty obvious. RISC-V is unlocking the opportunity for anyone to innovate, and driving quite a lot of disruptive dynamics in the hardware ecosystem, sort of previously closed proprietary innovation, and then now we're starting to see the ability for anyone to actually innovate at the programming level with new designs and new business models. So I think those are some of the rough similarities. Going back to the standards, sort of the independence of open standards and open source, that's potentially one of the distinctions, but I'd say that maybe going back to Linux, we had this kind of common way of interacting with machines through this sort of kernel interface that became sort of a standard, but along with that, there was sort of this dominant, very widely distributed implementation, which is Linux. So it's sort of the standard and the implementation kind of combined, and I don't think we've seen anything to point to that type of similar implementation and open standard in the RISC-V ecosystem anyway. Maybe that will occur, but I think what's more important is the hardware universe starts to sort of appreciate that there's this rising open standard, and that can kind of unlock lots of innovation. I guess one parallel in terms of sort of company dynamics, sort of commercialization dynamics, would be that the sort of value creation is something I think about quite a bit. Value creation and value capture are two independent things. Sort of when you have a closed, proprietary, centralized company, the value capture is largely tightly coupled to that company in terms of what type of innovation output is coming out of that company. So in the case of ARM, it's custom designs. In the case of Intel, it's more of a full stack kind of experience where there's the designs and also the development of the cores and the processors. With RISC-V, there's a huge amount of value creation going on. But instead of centralized value capture, we've got sort of disaggregated value capture, which I think it presents lots of exciting opportunities.
Very good. In my work, I run into a lot of engineers or engineering organizations that got caught up in the free of Linux, and then they start trying to commercialize it, and they realize, oh, this isn't really free. So in that sense, Tim, can you give us sort of a rundown of what building a custom SOC would look like and where there are potential pitfalls and hidden costs?
Well, it's a big question,
right,
especially in front of an audience who make a living doing that, right? And I'm sure everyone's aware there's no one answer.
Right.
I mean, I think Rick, I was behind the stage, and looking at it in a mirror image, but I think Rick sort of stole my thunder a little bit with the pie chart of some of the work we've done on a sort of medium complexity SoC, where design cycles can be 18 months, 2 years, depending on whether you're doing grounds up design or whether you're iterating something that already exists. The fully loaded costs when you think about tools and people and compute, IP can run into easily sort of $100 million plus dollars. Right. And when we sort of start to break that down, it's no surprise that probably two of the biggest elements of that are verification and software development. They really do tend to suck up the most time and effort and resource. And I think verification in particular is a really complex problem to solve. Again, depending on what you're producing. If you're designing a device that's effectively an open system, anybody's writing software that can go and run on it. There's the verification space is pretty much infinite, and it's not just about does it functionally work. It's does it work in a performant way, and that's not CPU megahertz. That's can you move data around the system? Is it secure? Is it functionally safe? We're moving into a world where more and more of these chips are going into environments where they need to be functionally safe, and all of these are additional costs, design costs as well as verification costs. I think if you sort of contrast that at the lower end, then there's clearly ways of creating silicon for significantly less than the sort of 200 million, 100 million, whatever I was talking about before. And I think that's a really interesting world, and a world where we're definitely involved. For years we've had low-end embedded processors and trying to unlock that capability, and that's where again, over the last 2 days and previously, I really see that community platforms, mixtures of open standards, open source hardware, software. That's what's going to enable people to create these low-end trillions of devices for sort of very bespoke endpoint applications. And we've been working with a company called eFabless, who for me have a kind of real visionary community platform that brings together developers, designers, IP providers, and enables people to create silicon. And we're talking $50, $60K to create a simple embedded endpoint. So really difficult question to answer, but very much depends where you're headed, what risk you want to take. But these are at the high end, they're long design cycles with big costs.
Very good. Krste and Mendy, we'll start with you, Mendy, but it's the same question to both. Where do you see opportunities with your respective technologies of disrupting some of that traditional design cycle that Tim just mentioned?
Sure. So I come from a world where it's $500 million to build a chip at the very high end, right? And so what we see is really a change from SOCs, which will still exist, but really to more of a chiplet form factor, where you're in heterogeneous computing, domain-specific built chips. And that's where these open standards and high-speed buses come in, to where people building SOCs have had to spend so much time, verification, NRE, you name it, or even just years in legal discussions about, licensing, to where, the part that's really their innovation doesn't get the focus, doesn't get the time, and doesn't get the dollars. Mm-hmm. They're spending so much time putting on die the part that's really common. And so if you look at the chiplet structures, you can say, hey, the commonality pieces, everybody can benefit, and then we can focus our time and energy on the innovative piece. Mm-hmm. And that's what I think is really going to come about with the end of Moore's Law, the data explosion, and new ways of thinking of how do we tackle these challenges. How do we do acceleration? How do we disaggregate across the system? So I think we're going to see that shift, and it's going to be helpful to everybody, because you can really focus on where your expertise is. And that's where we're going to see the dollars come down in the business model as well, right? You're going to see that you're no longer having to spend all that money on pieces of IP that really aren't your value proposition.
Right. Krste, same question.
Yeah, so I think I'm going to focus first on open standards. How does open standards help you building SOCs, reduce your costs? Actually, back to Joseph's point when he was talking about there's a single artifact mixed with the interface in terms of Linux. I think for the RISC-V community, we actually look up rather than look down the stack. So the really important infrastructure that we'd be building and sharing is the software ecosystem for a given platform. So say in RISC-V land, you may have, say, 3 platforms, IoT MCU kind of platform, application processor for a mobile platform, high-end server platform. And what the real value of RISC-V is having the community build a single software ecosystem that targets that. That's the single artifact that brings a lot of value to this open standard, having that available. Now, below that open standard, people can innovate and build their own hardware implementations, and it's great to have a great diversity of implementations available there. Now, how this helps SOC costs, what I see, proprietary standards really add a lot to that SOC cost. The reason being that, if I can't find the core I need, and I have to go to a different ISA from a different proprietary vendor, I now have multiple disjoint software stacks I'm trying to lash together. So in SOC designs now, I see 10, 12 different major blocks, completely different software stacks. And a lot of reasons, there's no particular reason they have to be different, but a lot of the verification, validation, integration costs are from dealing with this ununified kind of mess that current SOCs really are. Mm-hmm. So one of the goals originally in RISC-V is let's try and figure out how to build a base which we can use across the entire SOC, not just in a few places. And the other big advantage of an open standard, you can have a big community providing a great diversity of implementations. So now I can find the thing I need, working with the standard I want, rather than relying on no one company is big enough to provide the diversity of cores that people need. The second part is, you're spending all this money on an SOC. You'd like it to look different from your competitor's SOC. If there's no differentiation, you're not going to get a return on that investment. Mm-hmm. So, to really enable your team to, harness their creativity, do something different, the open standard lets them do that while retaining not having to redo the most expensive part, which is the software verification platforms that all work for that common standard.
Good. Joseph, that was a great segue, because the next question is, one of the advantages of some of the existing technologies that are in the marketplace right now is the software stack, that all the software infrastructure that's available. What are the options in OpenPOWER, RISC-V, and some of the other emerging open environments?
What are the options in terms of?
So where the same software infrastructure isn't available as is with ARM and x86, et cetera. So where does someone developing on RISC-V or OpenPOWER, where do they turn?
I think the vendor. So you may be asking about the partner vendor kind of ecosystem.
Yes,
to kind of help that. We've as part of our investment firm have looked really closely at the RISC-V startup ecosystem. We've made a couple of very early investments there. I think the work that SiFive is doing is really valuable. Obviously, Krste is part of SiFive. There's, I believe, exhibitors here, sponsors to the conference, so that you can kind of, as an attendee, start to see the sort of global activity in the vendor world. Going back to something I was saying about value capture disaggregation, when you have value capture sort of unlocked from sort of a centralized vendor, this is sort of a really significant sort of stimulant for startup innovation and for technology company innovation. And I think we're just going to see more of that. One of the theories early on that we have is RISC-V will sort of further disaggregate the centralized kind of hardware manufacturing pipeline or sort of supply chain, and provide lots of opportunities for domain-specific startups and domain-specific kind of companies to form that are really betting their companies and betting their engineering efforts on this open standard. And one thing that I'd say, kind of going back to something Krste was mentioning around sort of removing heavy lifting of undifferentiated sort of development. If you go back to the origins of open source, which is sort of reframing Richard Stallman's free software from 1983, about 15 years in, a group of people in 1998 came together and sort of defined open source as a way of innovating and developing technology and software in the open. And a few years after that, there's a really good paper that not many people know exists, written by Bruce Perens, who's the author of the open source definition. It was called The Emerging Economic Paradigm of Open Source. And in that paper, and this is before Git and cloud computing and many things in 2005, it was actually really emphasized that open source allows businesses to delegate undifferentiated heavy lifting to a permissionless kind of ecosystem of contributors and developers. And I think we're starting to see the same thing with RISC-V, is this sort of undifferentiated heavy lifting is now being disaggregated away from centralized sort of monopolistic vendors as well as customers. And you can really start to see businesses focus more on the innovative parts of their designs and their stack. And this is really primarily enabled because of open standards existing and open source as really the fundamental sort of driver for a lot of this. And the startup ecosystem and the vendor ecosystem is just starting to sort of realize what the opportunities are, I think.
Okay. Moving into fragmentation interoperability, Mendy. When we're dealing with some of these open hardware initiatives, how are we going to rectify the need to customize and differentiate with the obvious perils of ending up with a bunch of different cores that aren't compatible and the infrastructure that follows?
Right. I mean, so with fragmentation, it's all about having that software ecosystem where you can have lots of cores being able to run and not having different pathways.
Right.
And you can have differentiation without messing up that infrastructure. And it is about the fact that you don't want two things being done in two different ways and going down different paths. If I look at the power instruction set, we've have a long history. I mean, we range from our history of embedded processors all the way up to supercomputers. And so the instruction set has all of that in it that's been built over years. And the software ecosystem has been built around that. And so we have a very strong, robust, mature ecosystem that doesn't have the fracturing. And it's true, as someone comes in and wants to build on the instruction set, why would they want to go off of that? I mean, they get the value of that software ecosystem. Not using that, they're going to go build their own software, which nobody wants to do that. And so there is a benefit that comes into when that software is already there for you, that you can come into that ecosystem and really get the benefit of it versus going down and fracturing it. But there is things that we have to put in place in order to continue to govern that, to make sure that you don't get rogue players, and then part of that is the the partnership and the ecosystem as a whole being together saying, look, we want to have a strong software ecosystem that everybody can use, and that we have to have the right hooks in order to have all the differentiation across the product lines and the different markets.
Very good. Krste, same question, except this time I want you to put your SiFive hat on. So when I look at some of the design wins that are public from SiFive, some of them hint at being custom core implementations for a specific use case for a specific customer. So does this have the potential to veer away from what's happening in the larger RISC-V ecosystem and potentially create fragmentation, or how are you approaching that?
No, I think what's important to state is proprietary ISAs create fragmentation. You cannot innovate without fragmenting in a proprietary ISA world, because if you cannot get it from the vendor, you're forced to do it yourself. You have to do it differently. So you are forced to fragment and do something different. Like I mentioned before, a lot of the costs in the SOCs are all these different things that had to be different because proprietary licensing wouldn't allow them to do those things. So in the RISC-V world, you have an open standard, and from the very beginning of the project, we designed it to be an open standard that could run a very large, stable software ecosystem, allow you to innovate on the side. And so, no, there's no danger of fragmentation here. When we customize the cores, a lot of cases is actually below the ISA level. So for example, a lot of our customers, one of our big areas at SiFive, we're getting a lot of traction is in SSD controllers. People need a 64-bit embedded core that's high performance multi-core. It's very hard to find that elsewhere. That, again, a single vendor cannot provide everything in the entire market. There's a lot of diversity of microarchitecture that does not change the software interface at all. So you can innovate in the microarchitecture. You can also innovate by adding custom instructions that are set aside in a way that they don't interfere with the standard software stack. So again, proprietary standards cause fragmentation. Open standards avoid it. And again, the community really, there's a lot of forces, like I mentioned in the keynote, that bring people together. The first one is customers are very wary about being locked into another vendor. So customers, now they see the opportunity of there being an open ISA ecosystem. They don't want to go back to proprietary lock-in. So they will not, if you require them to buy this thing, they're not going to, no, we want a standard thing, because we know there are 7, 8, 9 other RISC-V IP vendors we can go to. So the customers are a big force to avoid that. The second one is the software ecosystem. Again, this is the most valuable piece. And if you go off to the side, you're going to have to rebuild that yourself. And nobody can afford to rebuild that software ecosystem and maintain it.
Okay. Tim, I've heard from several vendors, middleware providers to be specific, that in ARM's efforts to maintain uniformity through things like embed, et cetera, that you've kind of eaten some of their lunch. So how do you, at ARM, how are you approaching maintaining that uniformity within the architecture and the software ecosystem that surrounds it, but also allowing your players, your ecosystem players, to innovate?
Yeah, I think so, to respond to some of the things I heard around differentiation, as Krste said, it's where do you want to differentiate, right? And I think it's self-evident that the ARM community has been able to innovate and differentiate across products, and perhaps the commodity is the CPU. There's a sort of irony here that we created. Going back to the value capture, right? We said we're not going to take all the value, we're not going to build a vertical, we're going to share the value and allow everybody a level playing field to innovate. And that's been successful, right? But what was successful in the past doesn't make us successful in the future. I think where we'll never sort of quite agree is around the governance of the architecture and the levels of importance of that to enable a software ecosystem. So take away for a minute the single vendor thing, just as a problem for the software ecosystem. Having strong governance has enabled things like the Android store to grow and whatever the mobile phone the app runs, and that comes through strong architectural governance. So I think there's parts of the ecosystem where you need to keep that strong governance. There's parts where it's perhaps not as important. And we need to continue to, as I say, to evolve and help our partners do the things they want to do. And we see it. We see it now. People want to differentiate in different ways. At the very low end, the differentiation isn't really through the CPU. Again, yesterday in one of the keynotes, there was a comment about it's not about PPA, it's not about core marks, and it isn't, right? At that low end, it's not about that. It's about how quickly you can get to the data. That's what people want to do. They want to use devices to harvest data and monetize or do whatever they want to do with their data. And that's really about the developer community, right? It's how quickly, at one level, how quickly can you get people to the silicon solutions they need, and whether that's differentiated at architecture level, at microarchitecture level, or at the system level, how quickly can you get them silicon and a developer environment that enables them to securely connect to whatever they want to connect to provision their devices, to be able to do things like over-the-air updates, and get to the data, get to the money. I mean, that's the reality, right? And I think it's all about our developer environment. It's all about enabling that secure provisioning, and to a certain extent, making sure people can get to the right silicon as quickly as possible. As you move up the stack, you look at the community of people creating embedded devices on ARM. There is plenty of room for differentiation with accelerators, with RISC-V cores, with DSPs, with specific ML software. There is plenty of opportunity, and people are doing, and the complexity of those devices is going up.
Okay. Joseph, any governance lessons as it applies to what we've just been talking about?
Excuse me.
I think there are two types of governance approaches that are roughly generalizable, but the topic of governance in emerging open standards ecosystems and open source in particular is pretty complex, so this is an oversimplification. Pretty gross oversimplification, but I think it touches on a couple things that Tim was saying. Sort of single vendor governance and multi-vendor governance. We've seen actually examples of successful ecosystems grow using both approaches over time, evolving from one or the other or sticking with one. Taking Linux, for example, Linus Torvalds is still arguably the quote unquote benevolent dictator of the project. I don't really like that term benevolent because humans can never be permanently benevolent. It's just humans have flaws, and then no one wants a dictator running their technology. So maybe the term there isn't really the best term, but that's sort of like single entity, single person governance, and lots of examples of successful evolution and innovation pursuing that kind of approach. With multi-vendor ecosystems, we've seen a significant amount of projects be really successful, and also unlock large vendor ecosystem opportunities. So things like Kubernetes, for example, which is sort of perhaps on par with Linux at this point, the largest, most active open source ecosystem on Earth. It's sort of quote unquote governed by many vendors. In the very early days, Google was the primary governance entity behind the project, but over time that evolved to many, many companies. And there are tens of startups that have built businesses around Kubernetes that have gotten acquired with successful outcomes. There are several large businesses out there that are likely to pursue IPOs and many even larger outcomes. So the sort of idea that you have a multi-vendor or multi-constituent style governance, perhaps hampering or causing sort of issues or complexities for innovation, and maybe further challenges for a vendor ecosystem. I think that's a flawed sort of lens. With RISC-V early on, with the sort of really complex chip semi industry, I think the sort of stewardship and leadership and sort of evolving governance model that we're seeing now with the foundation, sort of opening up the opportunity for more sort of distributed governance beyond the creators of RISC-V, which include Krste and others, and SiFive's leadership. I think that's just a really healthy evolution of the open standard that is RISC-V and the innovation around it. But there's definitely examples on both ends of this.
Let me just comment on that. So our industry is based on literally hundreds of open standards. with many companies involved. Like the hardware industry is full of this. There should be no thought that you need to have some single entity controlling a standard. The whole industry, you look inside a laptop, I think there's a study, Arizona professors, something like 250 standards or something. So there should be no surprise that an open standard works with multi-vendor, because that's what most things are in our industry. This is just one more example, RISC-V of an open standard with multi-vendor governance.
I agree.
Okay. I want to make sure we leave time for the audience to ask questions, so this is the last section. Let's try and keep our answers to a minute, okay? So Joseph, obviously a lot of reuse of code in the open source software world. How do you see that playing out in the open source hardware arena?
Krste and I were just talking about Rocketship, which is the sort of base SOC design that SiFive's built to sort of speed RISC-V core development and sort of standard base. I think reusability is a big benefit there. So people don't necessarily have to redesign the entire, sort of construct the entire SOC from scratch based on the RISC-V ISA. Obviously, reusability in terms of libraries and languages and code in the open source ecosystem is responsible for just, I like to say hundreds of trillions or maybe quadrillions of dollars in value creation or sort of, undifferentiated heavy lifting removal. So I think Linux Foundation has a stat where 90+% of code in basically every technology software company on Earth, is a sort of patchwork of open source code reused and sort of built on the shoulders of the open source ecosystem. And maybe over time we'll start to see similar effect and phenomena in the hardware world. Okay,
Krste. So that reusability is great, but also we're starting to enter a world where there could be some serious legal implications. How is RISC-V and the open source community in general going to address that?
Yeah, I think the first thing to note is I think roughly 100% of all the IP lawsuits so far have been on non-open source hardware. So, it's a fact of life in the industry. So just because you have an open standard does not mean somebody else thinks you have patent rights. And so, yes, lawsuits are a problem in the industry. Different companies have strategies for addressing that. Mm-hmm. So yeah, it's a fact of life. There's nothing about an open standard that changes that landscape, I think. Beyond, there is maybe hopefully the community gets behind ensuring this standard is protected, right? So in terms of patent IP.
Okay. Mendy, your other hat is at IBM. Obviously, IBM has a lot of resources, but in this arena, there are a lot of new startup type companies. How can they protect themselves as they move forward towards commercialization?
Yeah, well, actually, what's interesting that I find is that it's actually the bigger companies that are concerned in that they're bigger targets for the lawsuits than the smaller companies. Mm-hmm. So the smaller companies actually are seeing that, hey, they can go out, they can play in this field. You're not seeing a lot of lawsuits coming at them, but the larger companies are more concerned about if they go out there, they're a prime target for IP trolls and the like. IBM has a long history in open, going back from the beginning of Linux Foundation and being a driver around open source licenses. What we see is we really need to drive open hardware licenses and the proper licensing in order that everybody is fully protected. And then once we establish that, go further in, on the open source software side, there's OIN, which is a pooling of patents, which IBM is a part of and help drive that. We see the same for open hardware. IBM has a large patent portfolio. When we put out the instruction set, we put our patents with it. When we put out open designs, we put our patents with it. And we're looking to work with the industry not only to drive those open source hardware licenses, but also in the future look to drive a similar establishment like OIN for the open source software world.
Very good. I just want to give you an opportunity, Tim, real quick. This isn't to say that ARM does not participate in the open source community at all. That's patently false. So what is the role of open source going to be moving forward, particularly on the software side, for ARM strategy, for your roadmap?
Yeah, I mean, yes, we do participate in open source, and again, it's quite a difficult position to sit in, with the people here. But yeah, we made huge contributions, right? I think there's, without being too corporate, there's around 1,000 software engineers in ARM contributing to open source projects. We clearly contribute to the open standards that have been talked about today. We've either creating them through things like Amber and our platform security architecture, or through participating in open standards. So that continues. I think it's sort of where you, in a sense, where you draw the line. Around it comes back to that architectural governance and what fundamentally do you believe is the right model to enable the technology. And I think absolutely I see a world where open source hardware will play a part in SOCs, and I think it'll be like open source software world, where there'll be a mixture of proprietary and open or open source. And you see that in the RISC-V world, right? SiFive, Andes, these guys, they're not open source implementations of the processor. Nobody here has claimed they are, right? But they will appear in chips and alongside open source hardware. And I really believe for this kind of the long tail, this kind of the innovation that's been talked about to create that, it is all about that enabling through community platforms, through collaboration. And I'm not on the payroll, but I'll go back again to people like eFabless, who are creating models that really work. They have RISC-V, they have an ARM design on their platform. It's bringing communities together, mixing open source with open, with proprietary, mixing tools, mixing IP. I think these are the models that are going to fuel innovation. At the high end, if you're AWS deploying servers, you're not going to be using these community platforms. But for many people, that world needs to be opened up. So I see that's how ARM will participate and show up, and we'll be there. We'll continue to make contributions.
All right, thank you. So we have a few minutes left. Anybody with any questions, feel free to come up. Mics are on either side. Yes, sir.
Yes, unlike what Krste said at the beginning, that open source hardware is basically software that describes hardware. When I talk about open source hardware, I'm talking about actual hardware. And I'm surprised to the extent to which people who talk about open source hardware seem to be okay with the idea that everything is open until you pass it off to a closed source EDA tool. And I would like to know if anybody would like to address the idea that open source hardware is not truly open until you own it all the way down to the transistor level, and how you get past the two full stops, one of the closed source proprietary EDA tool and the closed source proprietary foundry process.
Yeah, I mean, absolutely. When I talk to people, you can have the IP, but unless you have a whole open ecosystem where you can develop that IP and have open EDA tools, we're not there. And that's a road that I think we'll all be collaborating with. It's not architecture specific. It's how do we grow that full ecosystem out of all proprietary aspects of the design flow. And so that goes through the design into fabrication, but also, as you said, you got to look at the fabrication technology as well, and how does that work? But we have a long road to go to get there, and I think a number of people probably remember it was a long road in open source software as well to create that, and hardware's got different challenges. But I think we may be able to go faster this turnaround because we've had that experience through open source software.
And it's happening, right? I mean, you've seen here today in projects like Open Road, it is happening. So, yeah, I think, again, as an industry, we work together on, it's much easier for me to talk about that, right? But it's happening.
Sir, quick questions.
Yeah, echoes a bit this. So, I've been involved in Linux since about 95, before it became whatever it is. And at the Linux level, you could very early on, as an individual contributor, make a substantial contribution. So if you look at it now on the hardware side, on the PCB side, you got stuff like KiCad, and you could rapidly get yourself some PCBs at an individual level. really hard to see how this can still be done on the hardware side. The tools aspect was just mentioned and also was just mentioned this morning. But the turnaround time also as well is something that on an individual basis is quite a challenge. I mean, even if you go through Moses and you use Magic and whatever it is, you're still looking at months of turnaround. So the granularity of the increment here is different, it feels. And I was wondering if I could get some thoughts from the panel about that stuff.
Well, one thing I want to say, like the open source hardware movement, obviously deeply involved in this and done a lot of work throughout the years here. We shouldn't wait until declare success only when absolutely everything is done. There's a lot of big success at each stage of opening things up, from the standard to implementations to tools to foundry rules, foundries. As those happen, each of them will unlock a lot of value. But you don't have to, wait and be puritanical. I'm not going to do anything until everything is open. We can create a lot of value and get things going. And also, as each stage advances, it helps motivate doing the next stage. It's just very hard. There's a lot of steps. So at SiFive, we created SiFive actually. We wanted there to be more hardware innovation. How do we enable people to get to do silicon? And it's a challenging problem. There's a lot of, we've been trying to work with the whole ecosystem to put together a new platform so people can get to silicon quickly. Now, the many-month turnaround, there are magicians in the fab who do these amazing things. It's amazing. It only takes 3 months to make this amazing piece of silicon. I don't know, physics is kind of preventing us from doing any better in terms of turnaround time. So that's an unavoidable part of, you don't have that instant gratification you do with software. There is a long delay there and a massive investment. And because of that long delay, you invest heavily in verifying, making sure it's absolutely correct. FPGA is an alternate platform that a lot of open source hardware is actually targeting FPGAs. And they're a great platform for a lot of projects, even products. I think one step that we do need to do is RISC-V is an open processor standard. We need an open FPGA standard also. That would be, to me, the next logical step, which would enable opening up a lot of CAD tools targeting that open FPGA. And this would then bring out the next level of development, and then you can push towards fully open down to the foundry level. So I think the next thing is and there are people looking at open FPGA standard is really the next step, I think, in marching down this stack to open hardware.
I apologize, guys. We actually ran out of time. If you have questions you'd like to ask the panel, we're going to be exiting stage right. But I want to thank all of our panelists today. Very insightful. And judging on the interest, we're going to have to do this again. All right. Thank you.